Dear students, Yuva Zoology Academy starting online and offline coaching for MSc Zoology entrance for all universities and JL Zoology and DL Zoology competitive exams starting coaching from 1st December 2024. So call 7095986143 to book your seat.
So here the resting membrane potential exists because of a small buildup of negative ions in the exoplasm along the inside the membrane and an equal buildup of positive here negative outside inside the, so this is the axon, inside negative outside positive is build up. This is called resting membrane potential. So here such a separation of positive and negative electrical charges is in the form of potential energy. So in the neurons the resting membrane potential ranges from the minus 40 to the minus 90 millivolts. A typical value is the minus 70 millivolts. So here minus 70 millivolts electrical potential energy is present inside the along the length of the axolemma. At resting potential phase, the axolemma is polarized. Poles are present. Polarized means here poles are present. Here positive, negative, positive, negative. This is called poles. Outside positive pole, inside negative pole. Two poles are present, so called polarized. The membrane potential can change from its resting value when the membrane permeability to particular ions changes. If the inner side becomes the less negative, it is said to be depolarized. Means whenever the outermost positive ions, when they enters into the inside the exoplasm, then what happens? Inside positivity is created and outside negative is created. So inside positive, outside negative, the changing of the positive and negative along the length of the exoplasm, that is called depolarized. Poles are depoled. And then if in the exoplasm more negativity is present and outside only less positivity is present, so more negativity inside the inner side becomes more negative, it is said to be hyperpolarized. So during the resting phase, the activation gates, during the resting phase, suppose here this is the resting phase, means positive, positive, positive outside, negative, negative, negative inside. In this stage what happening? Activation gates of sodium are closed, the inactivation gates of sodium are open, and activation gates of potassium are closed. So here sodium activation gate, sodium inactivation gate, and potassium activation gates are present along the length. Just now we discussed. Whenever in the outside positive, inside negative, when there is a resting membrane potential, what happening on the membrane? See here, two gates are closing, one gate is open. What is closed here? Sodium activation gate is closed, potassium activation gates are closed, only sodium inactivation gates are open. So the inactivation gates of sodium are open only, that is called resting membrane potential. Here on the leakage channels itself, on the ligand channels, on the voltage gated channels, in the channels itself, then the channels are present, those are called sodium potassium pumps are present. What is the work of these pumps? Leakage channels, if they are open, always some leakage of sodium, some leakage of potassium, both are moving here and there on the membrane. It never maintains the minus 70 millivolts. So to make the control on the leakage channels, there are sodium potassium pumps are there with ATPase enzyme activity, means by requiring the energy 3 sodium ions are in flux, only 2 potassiums are comes outside. This maintenance is called sodium potassium pumps. So if look here, sodium and potassium ions diffuse inwards and outwards respectively. Means sodium diffuse inwards, potassium diffuse outwards. So always positive, outside positive is there, means sodium is present outside, inside negative is there, inside potassium is present. So potassium is going outward, sodium is coming inward. So outward, inward, how many sodiums, how many potassiums are go outward and inward, that is maintained by the sodium potassium pump is there. So every 3 sodium ions are in flux, there are only 2 potassiums are going up. This maintenance caused due to the sodium potassium pump. So here 3 sodium ions for each 2 potassium ions imported. As these pumps are remove more positive charges from the exoplasm than they bring into it. So they contribute to the negativity of the resting membrane potential, that is minus 70 millivolts. So to maintain the minus 70 millivolts, it is necessary to maintain the proper movement of the sodium and potassium ions. Every 3 sodium ions in flux, there are 2 potassium ions outflux is there because of the sodium potassium pump. So already we discussed depolarization. Poles are changed. Outside positivity is there, inside negativity is there. Whenever there is a signal is passing, then positive sign enters inside and negative sign enters outside. That is called depolarization. Look here, when a nerve fiber is stimulated, the plasma membrane first becomes more permeable to sodium ions. So plasma membrane of the axon first permeable to the sodium ions, then to the potassium ions. As the activation and inactivation, voltage gates of the sodium open and activation voltage gates of potassium are closes. So here along the length of the axon, there are sodium, another sodium, this is activation, this is inactivation pump, this is the potassium activation pump. Potassium activation pump is closed, whereas the sodium activation, sodium inactivation gates are open. In this condition, what happens? The sodium influx takes place, so negativity in the inside becomes the positive and outside becomes the negative. Actually this is the resting potential. So resting potential is like this, but changed the signs, outside negativity, inside positivity, because of the sodium ions influx and potassium ions slowly they are going outside, but the gates are closed, so potassium never goes outside. So sodium coming inside means positivity is less in the outside, means becomes the negative charge. Outside negative, inside positive. Actually outside positive, inside negative. This is called resting potential. This is called depolarization. Both are called polarization. So what happening here? First half is the dipole and second half is always a resting potential. Means the changing of the poles are taking place slowly, and when it comes here, so like that minus charge going up and positive charge entering inside. So whenever you are seeing it in one place, depolarization, immediately there is a resting membrane potential. Both are exist. This changes. So minus plus in the side by side, and here plus and minus side by side, total, that is called action potential. So the signals along the length of the nerve fiber, they can move, transfer to the brain in the form of action potential. Resting membrane potential is minus 70 millivolts. Whenever there is a chance of making of signal, the information, suppose an ant is moving here, that ant bites here. When it is bites, that biting is creates signals. So that signals changes the minus 70 millivolts to the minus 55 millivolts. This minus 55 is called as a threshold potential. When it bites, then we analyze something is biting us. So that biting creates action potential, and that action potential, biting is also known as the threshold potential. Threshold potential is minus 55. It creates action potential. Then along the length of the fiber, the signals are moving, information is moving, that is ant is biting, information is moving throughout the length of the axon by the changing of the poles on the membrane, because sodium ions are in flux, potassium ions are not coming outside based on their sodium potassium pumps and leakage channels. That is why outside negative and inside positivity created, that changes in the charge, that is called action potential. Nothing but information or nerve impulse is created, signals are created and moving along the length of the nerve fiber. Repolarization. Repolarization means here, suppose this is the length of the nerve fiber. First, positive, 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 negative, negative, negative. This is called resting membrane potential. It's converted into action potential. Action potential. Further, there is another positive, 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 and here resting membrane potential. So when this action potential moving on, so here once again negative, 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 positive, positive, positive. Immediately, suppose it is moving here, immediately this also once again converted into positive, positive, positive and negative, negative. Means once dipole created, is dipole moving in the further direction, immediately from the back side, repole also taking place. Repole means ready to take another potential, that's called resting membrane potential created here. So positive, 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 negative, 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 this is the resting membrane potential. When this outside negative, inside positive is called action potential. Action potential moving in this direction. When it is converted into the negative and positive inside, immediately the back side is once again reforms the positive and negative. Immediately it reforms. The signal is moving on there, but here once again repolarization taking place, means outside positive, inside negative, once again taking place. So here repole is taking place, here dipole taking place, okay, and there is the resting membrane. So repolarization, polarization and resting membrane potential all are on the length of the membrane. And if you see in the long distance, what is you are seeing here, when an ant bites, outside negative, inside positive creates. The information is moving on. That is called dipole. But in the before there is a resting membrane. Resting membrane once again is depoling. It is going that direction. From the starting point, repole is taking place. Repole means outside positive, inside negative, once again creating from the back side. This is called repolarization. And here hyperpolarization. Hyper means the same, outside positive, inside negative only. Why it is taking? Because of sodium ion gates are open still. After repole also, they are still open. They are very lazy pumps are there. So sodium, potassium is always going outside and removing outside. So more negativity created in the exoplasm. That is why outside positive, inside more negative. That is called hyperpolarization. And this diagram shows the total the nerve impulse and conduction of a nerve impulse. Look here. First, in the resting potential, outside positive, inside negative is present. Sodium gates, potassium leakage gates are present here. And reaching the threshold, biting creates minus 55 millivolts of power. That is called threshold reaction. So in the threshold reaction, the nerve starts depolarization. So dipole started here, outside negative, inside positive created. Okay, and why it is created? Because sodium inactivation, activation gates are open, but potassium gates are closed. So that is creates the more negativity outside and more positivity inside. That's called depolarization. Immediately there is a repolarization taking place, outside positive, inside negative taking place, and still the potassium gates are open when there is a sodium gates are closed even, but potassium gates are still they are open. Then what happened? The more potassium going outside and more negativity in the inside, that creates the hyperpolarization, and once again they are coming to the resting state. This is called generation and conduction of nerve impulse. Okay, on the synapse. Synapse is the gap between the two neurons is called synapse. In that gap, what is happening? That is called synaptic transmission. See, this is the axon terminal. Actually, axon terminal is there. So I am drawing the same diagram here for your better understanding. Cell body, axon, axon terminal, synapse, postsynaptic region. This is called postsynaptic region. So here, what happening here? A neurotransmitter is created in the cell body and sliding toward the length of the axon, entering into the knob of the axon terminal, and then it is the neurotransmitter releasing into the synapse, and after postsynaptic membrane, the ligand gated channels are there. They receive the chemical neurotransmitter and they open the ligand gates. After opening of the ligand gates, the signal is passing from one neuron to the another neuron. So what is happening in the synaptic region? That is called synaptic transmission. Look here, this is the axon. A neurotransmitter with a bag is coming. This is the neurotransmitter filled bags. This is the axon terminal is there. When they are reaching in the axon terminal, this is the presynaptic region. This is the postsynaptic region. This is the synaptic region. So when these neurotransmitter bags are touched with the synaptic region, releases the neurotransmitter in the synaptic cleft. This is called synaptic cleft, and these channels these are called ligand gated channels are there. These channels, these ligand gated channels, they receive the neurotransmitter and then they are open. So what is happening in the synaptic area? The neurotransmitters are coming and touching the presynaptic region, releases the chemical into the synaptic area. In the synaptic cleft, there are ligand gated channels are there and they are open in the postsynaptic region. The information from this neuron enters into the another neuron. That is called synaptic transmission. So the best neurotransmitter is called acetylcholine, the most common one, and also epinephrine, nothing but adrenaline or adrenal gland releases the epinephrine, adrenaline hormone. So epinephrine, norepinephrine, dopamine, serotonin, other neurotransmitters, but most common is the acetylcholine. And the postsynaptic membrane has ligand gated channels. They are ion channels. They respond to the chemical signals, ligands. So rather than the change in the membrane potential, so the entry of ion can generate a new potential in the postsynaptic neuron. The new potential developed may be either excited or inhibitory action. So excitator means activation of the process, inhibitor means stopping the process. Whatever it may be, the neurotransmitter stops the action or enhances the action. So basing on that neurotransmitter, the action is going on. If it stops, that is called inhibitory neurotransmitter, and if it is activation, is called excitatory neurotransmitter. Okay, so this completes the generation and conduction of action potential along the length of the axolemma. So the membrane of the axon, are also called a nerve fiber. Thank you so much.